Hello and welcome to the video. In this video, we're going to have a look at how do we find the Fourier series of continuous time signals. So let's get started. So the topic is Fourier series. Now, obviously, the Fourier series will be found out for a signal which is continuous time in nature. So this can also be called the continuous time Fourier series or simply Fourier series. Okay. Now, the idea is very simple and straightforward. Let's assume that x of t is the given continuous time signal which is periodic. Now, I can always find the Fourier series coefficients of this signal. This signal has the fundamental frequency of omega naught, and the Fourier series coefficients will be represented as x of k. Now, if I have x of k given to you, you can always find out the value of x of t once again. So x of t and x of k are said to be the Fourier series pair. So let's try to look at the defining equations. First of all, x of t can be written as summation x of k into e raised to j k omega naught t. The value of k will range from minus infinity to plus infinity. I just want to draw your attention to how we had done the same thing in the discrete time domain. In discrete time domain, we had written the equation as x of n is equal to summation x of k into e raised to j k omega naught n. Now just look at the similarity. Now this first equation is called the synthesis equation. Here we have the value of x of k given by the equation 1 over t integral. Now this integration can be performed for one complete cycle or t period. X of t into e raised to minus j k omega naught t with respect to dt. The second equation is called the analysis equation. So these two form the defining equations for the Fourier series representations. Well, it is needless to say that the fundamental frequency here is omega naught. If I look at the values of x of k and try to plot them, now this is called the magnitude spectrum, just like what we had in the case of discrete time Fourier series representation. This is called magnitude spectrum. And if I look at the value of angles corresponding to the coefficients of x of k, then this is called the phase spectrum, just like the earlier case. So given x of t, I will be able to find x of k, or given x of k, I should be able to find x of t. So this is how the Fourier series representation can be indicated. Thank you so much for watching the video. We'll see some examples in the next video.